is a graph that has points on it. So it really should look like a bunch of dots on a graph. But those points show a relationship of two sets of data. So depending on what you're comparing, you could compare height and weight. You could compare the length of time versus how tall something rose. You could compare two different brands of something. Like TVs, maybe you're going to compare the number of LCDs versus the number of LED TVs bought, or through, what do they have, like 3D TVs? Is that what, yes?
4K.
4K, yeah, that's that what it's called, 4K TV. So maybe you're going to compare like the numbers of the LCD, because that's the old TV in your mind, versus the 4K TV. I think I still have a plasma TV. I mean, it's still a skinny one, but whatever. My TV works fine. So with scatter plots, you take two pieces of data, you try and group them together, looking at like an x and a y value and seeing if there's a relationship between the two pieces of data. Linear regression and best fitting lines. Linear regression is the process of finding a best fitting line. So a best fitting line is a line that you would make, like I made a line here, that fits most of the points that you've graphed. So if I could take a line and fit it to as many points as I have graphed, with it still being a straight line, then that's called the best fitting line. Best fitting line is kind of like your average line. So if you would take all the points and average them together, average the slopes, average the y-intercepts that the lines would create, that would be our best fitting line. So it's a sense like an average line. But the linear regression, that's actually the way or the process of getting a line and calculating the equation of that line. So if I were asked to calculate an equation of a line by hand, you need 2 points to make an equation of a line. You need to find the slope using those 2 points. You need to find the y-intercept. With this, there are 2, 4, 6, 8. So there are 8 points up here. So I probably have to set each of those points with a pair and then find 4 different equations. Using those 4 different equations, we then average the slope, we'd average the y-intercept, and we use that to have a final equation, which that's like a lot of stuff to do for one problem. So that's why we're going to try and use the calculators to help us. The calculator will do that information. So the calculator actually does the linear regression process for you. It creates its own equation using the numbers you plug in. At the bottom is the other term, correlation coefficient. The correlation coefficient is a number, but it's the variable r. So that r represents a number between -1 and +1. It'll never be more, it'll never be less. That number tells us how well the set of data can be modeled to be a line. The closer the number is, the closer that r value is to 1, it means the more the graph should look like a line. So it's going to be like 0.95, or it could be 0.85, or maybe 0.75, but it's going to be a decimal, and it's allowed to be negative as well. But the closer that decimal is to the number 1, that means the graph that we have, like this graph right here, looks really close to being a straight line. So this r value would probably be like 0.98, because almost all of these points could fit to a line. So r tells you information about the data, how linear that data is, how close it is to making a line. But it also tells you if it's a positive or a negative graph. So if the r is positive, then my graph, my scatter plot, will be positive as well, or it's going to increase from left to right. Now, I drew a line through here because those points together, kind of as a group, they make a line. But it's nowhere close to being a straight line. Sure, the group maybe makes a straight line, but for it to be a straight line, like all those points need to be really close to being on top of the line. So this is still a positive correlation. The r value, maybe it's like 0.8, not close enough to 1 to making all those points fit on a line. So if we say we have a straight line, it's because every point is really close to touching a straight line. The negative correlation, so we'd have a negative r value. Again, as a group, this looks like it's going down. And then the last one is no correlation. If there isn't a correlation, the points are just scattered. When I look at this, it doesn't really look like they're going up, they're going down, like they're just kind of scattered. They don't form like a group forms a line. So they're just swarming all around, like a swarm of bees at a nest. Just kind of swarming in your graph. If that happens, your R value is going to be close to 0. I say anything under 0.5.
Oh, okay.
Yeah. Gotcha. So anything under 0.5, probably going to give you that there's not really a relation happening with the graph. And then a correlation, just so like the word relation is in there. So it really is just the relation between two pieces of information. So when you see the word correlation, it's really what's the relationship between X and Y? It is a fancy math word, correlation. Questions?
Is this about like correlation coefficient?
Yes.
Okay.
Yes. Other questions? Okay, so we're going to need the calculator. You might also want line paper to take down some notes so that you have notes for yourself as to how to use the calculator. So I've got like 4 different steps up here that we're going to look at. You can probably squeeze it in on the side of your page. If you write tiny, I bet you could probably squeeze it in on the side. And it's just up to you how neat you want to be. But if you have a 3-ring, like spiral ring notebook, put them in there. We're going to go through each set when we're supposed to, so we'll work through one at a time. And I promise, like by the time you do 3 of these, you'll have them memorized. So don't be overwhelmed that there's like a ton of notes on my board up here, directions. After you get through the 3rd time of entering data, you'll be good to go. So we have a T-chart here, or a table, dealing with the height and the weight of high school football players. There are 11 football players in this list, so we could do something for 100. I don't even know how many football players are on the football team. 60? But we could make a graph for all 60, but that would be a lot of data to insert into the calculator. So we have 11 players here. And the first thing that it asks you to do before we calculate anything is to make a conjecture. What's a conjecture? Mitchell?
It's like when you make a, you're like, I think this is going to happen, but I'm not sure, so let's test it.
Yeah. What is that called in science? An educated guess or a hypothesis? That's what they say in science, right? So a conjecture is just the math way of saying make an educated guess about the relationship between height and weight of football players. So how is height related to weight? That's what part A is asking. Sarah, how's height related to weight?
Like the taller you are, the heavier you
Yeah, so the taller you are, the heavier you're going to be. It kind of makes sense. If you're 7 feet tall, nobody's in here 7 feet tall, right? Let's say 6 foot tall, you're going to weigh more than me who's 5'3". So, and if you're male, obviously you're going to weigh more than probably the females do. So, what'd you say?
The taller person is the heavier they are.
Sure. And we'll make sure that Mr. Kane does not come down and critique our grammar. It's okay. Pretty sure you're not supposed to end a sentence with a preposition. I think that's one of his rules, but we're Matt. So if you can come up with a fancy, proper way to write that sentence, wonderful. Yes, this should be really he, she, will be. So part B says using your calculator, create a scatter plot. So we want to be able to take the data and come up with the points on a graph to see what's happening with that graph. So we're going to go over here to this board and follow the information. I have my calculator up here as well, so I'm going to pull that up so that you have a visual. So the first thing that we're going to do is we have to enter the data into the calculator so it can compute the information we needed to compute. To do that, you're hitting the Stat button, which is right here next to the arrows. We need to edit because we're going to add information in. So that's the edit function. You just have to hit enter. So it's already on edit. Just hit enter. And then the third step is you literally need to enter the data. To do that, you type the number 70 and hit enter, and then it bumps it down. So on your list, the height is L1 or the X. It's like a T-chart. The X is always the left, the Y is always the right. So the height is L1, the weight is L2. After you hit all of the height in, arrow over to the weight, and type in all of those values. But do them all vertically. So get like one whole column done before you move to the next. Don't try and arrow back and forth. Also make sure you're checking to see that the information that you're entering in is accurate. If you type in like a 78 instead of a 70, the whole data then is skewed. So you have to make sure that the numbers you're entering in are accurate, that your X's and Y's are matching when you're putting them in your calculator. So the calculator table should look like the one on your paper. Please let me know if you have questions about entering it. So if you have the data entered, then if you go to the left where it says to graph, you want to see if you can follow those steps where it says to graph?
Who's the data matrix or a lens?
The do you have instructions?
No, I couldn't find some. I'm sure it's
Let me know. Alright, so okay, so now after we're gonna go over here. So now we're right here. So after you have it entered in, your calculator screen looks like mine. We're gonna graph it. And to do that, we're gonna hit the second button, which is blue at the top. And then you're gonna hit Y equals. And the screen should look like this. So it has actually 4 different plots that we can do, but we're only going to use the first one. So if you hit enter, it turns it on, and you have to hit enter twice. So that's the first step and the second step. So second Y equals, and then turn the plot on so that it actually graphs a scatter plot and not a line. So now whenever you graph anything, you're going to see a scatter plot on top of your graph. So you'll have dots on there. And then we're going to do zoom 9. Zoom is at the top, that top gray line, and it's in the middle. The zoom function graphs your information in various ways. There's a zoom in and a zoom out, so that'll zoom in on a piece of your graph or spread it out so you can see a lot of it. There's also some trig functions that you can graph, but if you hit zoom 9, or if you want to scroll down to zoom 9, it's up to you. I just typed 9. That's called zoom stat. Really, this is a statistical piece of data that we're looking at. The graph is a statistical graph. A scatter plot is a statistical analyzing of like a graph or information. So if you do zoom stat, you then have a scatter plot shown on your graph without even graphing it by hand. So the calculator is doing it all for you. The last thing that we need to do to answer the question for part B, using your calculator, create a scatter plot, is to show the window. The window is the calculator screen. This guy here. It tells me your X value from left to right. It tells me your Y value from bottom to top. So that I'm not going to walk around and check all your calculators, or I'm not going to make you graph all of the points. But if you hit the window button, which is at the top, it tells me that you entered the information incorrectly. And it gives me what the left and the right of your screen are and the top and the bottom of your screen are. We should all have the same information if we use the same data values, except the scale, that X scale, Y scale, these guys might be different. And that just depends on what your calculator is kind of calculating the tick marks. That's okay if those two are different. So underneath where it says window, on the notes for section B, see if you can write the window down on your calculator. So again, this is my way of knowing that you put it in your calculator correctly and that you then graphed it into a scatter plot. And this is the easiest way that we can come up with to kind of see that you are plugging it in to your calculator correctly. So now we're pretty much done with the left side of the board. We are going to try and answer part C and D, which is coming up with an equation and finding the correlation coefficient. So that would be over here. What I have here in black to find R, you don't need to write this down. Once you do it once, it'll be on there forever, unless you're afraid that you'll forget about it. But as long as you don't delete the memory of your calculator, once you have this set up for your calculator, it should always be there. So to find R, which is the correlation coefficient, we need to hit second and the number 0. If you look above the number 0, it says catalog, and that actually tells you everything, every function your calculator can do. So when I hit second 0, it brings up the catalog. In that catalog, there is a word, 2 words, that says diagnostic on. That's where the R is embedded in that function. So you need to arrow down with your little arrow until you get to diagnostic on. And again, this is the only time you need to do it. Hopefully you don't have to do it again. After you get down to diagnostic on, if you hit enter, it comes up in your calculator screen, hit enter, and then it says done. So that's calculator saying, okay, I have that information now, I'm going to be able to use it when you go to do a statistical data analysis. The last set of information that we're going to do is to find the equation. So really there's 3 things that you'll need to do for every problem. You'll have to enter the data, you'll have to graph it, you'll have to come up with the equation. But you'll get so used to doing it that it'll be like a minute and you're done. So it won't take much time after you get used to it. So to get the equation, we're going back to that stat button. So you're going to hit that 2 different times to enter data to get an equation. The data is entered, but we need to calculate things. So if you arrow over to calculate, we are using linear regression today because we're talking about lines. Underneath it, if we talk about quadratics, those parabolas, we would do number 5. Numbers 1 and 2 would be if I want to analyze mean, median, mode, range. So there's a bunch of different things we can do, but we're going to look at number 4. So just type number 4. Your screen may not look exactly like this, and that's okay. It just depends what version your calculator is. If you have a screen like this, you need to enter down till you get to the word calculate, and then hit enter. So I think you have to enter 4 times. And then it should give you y equals ax plus b. And then it gives you an a, a b, an r squared, and an r. You don't need r squared. That would be if you're going to take AP Stat or Stat in college. So over to calculate. And then in letter C, see if you can take the a and the b and write it in equation form. And then enter a bunch of times to get down to calculate. There you go. You're good. Oh. Question. So it's given to you. You just need, like, this is your A, so you need to plug in A. And then B right here. I think it says 2 decimal places on there. Yeah. 2 is good. Always 2. Yeah. All right. So, Mackenzie, can you give me your equation you have?
Y equals 5.33x minus 209.50.
209.50.
It was 4.9. So I had 4.8.
That's 4.8.
Oh well, I rounded differently. Sorry. 4.8. Yeah, I rounded it to 1 and I just put
And then
zero
you
up
round, yeah, okay. So we'll say 4.8.
there.
The letter D is the correlation coefficient, and that's the R. So R is 0.84. And then it says, what does it mean? So what does the R value mean with this problem? Let's see. Is this positive or negative? So then it would be
I
a,
thought you said less than 0.
this is less than 1. It would be negative.
Oh, never mind. I'm sorry.
That's okay.
Positive correlation.
There we go. So it's a positive correlation. You could say that the points, like as a group, form a line, but it's not a straight line. But as a group, those points form a line. But it's a positive correlation, not relations. So as a group, the data definitely looks like it's going up, just not all of those points fit to a perfectly straight line. So that's what you need the calculator for. There are, I believe, 4 questions underneath that we're going to analyze and see if we can interpret what the numbers mean in the equation, and to try and use the equation to find some different things. So for E, it wants you to use this equation to predict the weight of a football player whose height is 5'11". So if I'm 5'11", and I'm a football player, how much should I weigh? That's what we're kind of trying to find here. So what do we need to do with 5'11"? Yeah, change it into inches because the data in the table is in inches. Do you know what 5'11" is as inches? 71 inches. And then do we plug that in for x or y in the equation?
For x.
Yeah. So x is 71 inches. So we're going to plug that in the equation and get its matching y value for the weight. Remember, there are 12 inches in every foot, so that gives us 60 plus the 11. Sarah, what'd you get?
How
Question.
How would you show your work?
Just plug, yeah, like, that's all you need. Show me that you plugged it into the right place, give me an answer.
168.95.
Yeah. And then this is the weight, so this would be pounds. Or you could write LBS. So this is an average weight for 71 inches. So if we went around and tried to find a whole bunch of people, football players, that were 71 inches, 5 feet 11 inches, and calculate their weight, on average, it should be 168.95 pounds. Now, the person that's in this chart for 71 inches is 155 pounds. It's not going to match up with the number from the equation, because the equation is your line of best fit. It's your average line. It doesn't have to match up exactly with the person that data was given for. So now that we use the equation to find out how much it weighs, there's a couple other things that we can do. F and G want you to kind of decide what the slope and the y-intercept are, and then to interpret what it means in this situation. So let's start with slope. Brady, if you have the slope of a line, where's the slope at in this line, or what's the slope? Yeah. So you don't need to calculate it because it's already in the equation in front of x, so he said 5.33. Brady, usually what does slope represent? Not in this problem, but just what does slope mean? Rate of change, good word. So how something changes, how quickly something changes. We also think of it as rise over run, so those are the two things that we think of when we think of slope. I'm going to put this over 1. So rise over run, y over x, however you want to think about that. how can we maybe create a sentence to describe what this means? Noah?
For every additional inch in height, there are 5.33 additional pounds.
Yeah. So she said for every inch that you add on your with your height, you're going to gain 5.33 pounds. The x is your inches, the y is the pounds. So as you gain 5.33 pounds, you're growing an inch, or as you grow an inch, you're gaining 5.33 pounds. However you can write that sentence so that it represents the numbers in the problem and it makes sense to you is fine. So you could say, as you grow an inch, you gain 5.33 pounds. Or every inch, you gain 5.33 pounds. Okay. The y-intercept. Again, we've got this equation. So Shaylin, what's the y-intercept of the equation? And every y-intercept has the same x value. What is that x value? 0. So again, x is our inches, y is the pounds. It wants you to interpret what this means. This one's a little weird. What does it actually mean if I have 0, negative 209.48? Mackenzie?
If you are 0 inches tall, then you weigh negative 248 pounds.
Yeah,
Point
that's
48.
kind of what it means. Doesn't make sense. But that's what this number, it means in this problem. So if you are 0 inches tall, technically you weigh negative 209.48 inches, or I'm sorry, pounds. Now, nowhere near being true, because if you're 0 inches tall, well, you shouldn't weigh anything because you don't exist. No.
Why does it end up with, is the data like inaccurate?
It's not that the data is inaccurate, it's just with that graph, the way the points are, it can't be a straight line and go through the origin. So just where the points are on our graph, the way it finds that best fitting line, it cannot create a best fitting line that starts at 0 and fit to all the points. So it's not that the data is inaccurate, it's just that where our points are is not going to go through the origin with the graph. And it will happen sometimes, not all the time. Sometimes it'll work out nice and make sense, and other times it just doesn't. The last question on there wants you to find the x-intercept. So how could we find an x-intercept?
To make y 0.
Yeah, just make y 0. So 0 equals 5.33x minus 209.48. So anytime you want an x-intercept, you make y 0. If I want a y-intercept, we make x 0. And I think it's 30, is it 39.3? And then that's in inches. Again, this one doesn't make sense either, because where it's crossing the x-axis is not at 0. It's crossing the x-axis at 39 inches. So technically, if you're 39 inches, according to this problem, you shouldn't weigh anything, which we know you wouldn't be alive if you were 39 inches tall and you didn't weigh anything. But math data doesn't know real life situation. So we try and match it up as best as we can, but there are times that it isn't going to totally correlate with what the problem is talking about. Questions?
Are you ever gonna have like 3 sets of data?
We'll be comparing two. So comparing an x and a y. If you compare a third, that creates the z variable, and then you have 3-dimensional graph.
Okay, but is it able to be scatter plot?
Yeah, you could put a third piece of information in there, yes. Yeah, it goes, I don't know how many lists it can go up to. I don't know if there's like 10 lists in there. Yes, you could create a third piece of information. Alright, so if you can find that worksheet that you got from the beginning of class. Anyone need another one? I went want to start this with you so that you have a head start and kind of thinking about the information. I believe this one will make more sense when you come to like the y-intercept and the x-intercept. So the data shows the number of U.S. households owning a computer for the years 1984 to 1994. This is percentages. So in 1984, 13% of households had a computer, which computers really, I mean, you were rich to have a computer in 1984. I know you don't really think about that way, but you had to be very well off. Even in 1994, there was only 37% of households owning a computer. I know we had one, and it was a green, like my computer was a box, and the screen was green, and it typed in white, and it was just block letters, but it worked. So percentages, keep them as a percentage, don't make them into a decimal. Years, remember we don't actually use years in the calculator. So instead of using 1984, you're going to use the number 0, because that was the initial year from what the data we have is given to us. 1994 would be 10. So make sure that you don't put 1994 or 1984 in the calculator. You're using a 0 and a 10. L1 would always be the top of the chart. L2 is the bottom. So if it's not vertical, top horizontally is L1, the bottom is L2. Same thing with X and Y. I would like you to graph this. So it says, does the scatter plot have a positive, negative, or no correlation? So graph it and give me the window up here. I inadvertently didn't put window. So if you could list the window for me after you're looking at the scatter plot, then I know that you have it graphed correctly in the calculator.
Are we changing the percent and decimal?
No, keep them as whole numbers. So keep the percentages as actual percentages. The back of the page talks about the height of a tree that was planted. So 2 sets of data, and then after you enter those data and you find your equation. So like once you find the equation, the rest of it is what's the y-intercept, what's the slope, can you interpret what information means. But it's entering that sets of data into the problem. I think after you get both of them entered, you'll feel pretty comfortable with the directions and how to use the calculator. So tomorrow we're going to do more of this, and we'll do an activity, and then same thing with Thursday. That I initially thought we were going to have time to do it, but we'll do it tomorrow. So it's just the linear regression for today. That's a really good question. How do you clear the data? If you go up to, really, really good question. So if you go up to L1, so make L1 bold. So you have to hit stat and then enter. So if you go up and make L1 bold, hit the clear button and then the enter button, and it wipes it all out in one swipe. And then arrow over to L2, clear, enter, and then it's all gone. Don't type or hit the word delete. That actually physically deletes that L1 from your calculator. Vanishes. And then you have to wipe out your memory and go back to the original memory to get back. So never delete, clear, enter. How about volunteer to show number 1, H and I, or number 2 on the back, J and K? Alice, you'll number 1, H and I, Allie, J and K. Yeah, awesome, thank you.
Wait, JK on the back?
JK on the back.
Sorry.